firebox. Inside the firebox, I have 150 feet of 3/4 inch copper tubing, which I meter steam through the copper and it comes out. In the center section is the steamer, and then the steam goes into the cooking chambers, and it's so hot that it condensates on the meat. When the water evaporates off the meat, it cools the meat so that the food doesn't dry at all, and you can actually make it where it won't reach boiling temperature if you put the right amount of steam in for the temperature. You can cook at 300 degrees and pull the meat out and it's still weigh the same thing. So this is my cooker. Here's the steamer. The steam comes out that tubing. I can put a box of oysters in here, a bag of oysters, and steam them in about 20 minutes. They get so hot they jump right out of the shell into the hot sauce to cool off. So here I got 6 4-foot by 4-foot racks with a drip system so that one rack doesn't drip on top of the other rack. Here's the temperature control. I have a thermocouple in here, so I'll set the temperature at say 300 degrees. When the temperature drops below 300 degrees, the fan on the bottom of the ash box will kick on, raising the fire up. When the temperature gets right, the fan will shut off, and as long as you put a little bit of wood on it every hour, you have no trouble with keeping a constant temperature. I can get both sides up to 350 degrees and maintain it. The temperature differential between the top, if the top is 300 degrees, the bottom rack is around 250, 275 for the middle rack. So you can space your food as you want to cook it. This started as a 24-foot long underground diesel tank. It was a 5-second God-given design. Pulls really easy. Now, the main thing that I want to discuss with you is the equation 1mass1 and 1mass1 combined. This is an equation that I wrote quite a number of years ago, that as I learned a little bit about Albert Einstein, it's the same as E equals mc squared. Neither actually exists because one object will rob the other one of its E equals mc squared. So 1mass1 basically says that if you have a mass, it's going to have equal force pushing toward it in all directions. So what I've done with this is I've created this material. As it stands now, when the wind blows across it, this will go toward the cooker. Right here, it will go and blow away from the cooker. Now this material, I created it using vinyl window blinds, and I cut them into strips and they came out as a perfect airfoil. This material is made up of strands shaped like an airfoil. It will either push down no matter what the wind speed, holding a roof down, or holding a race car to the track no matter how fast it goes, or for propulsion. Here, the material put on the house, on top of the roof, it can actually just get to where it's micro, little tiny dots of airfoils, and when the wind blows across the structure, it will push this way, and of course on the roof pushing this way. So the pressure that is on this side of the roof, it will counter it and remove the wind off of the structure. It go on top of cars, and you go as fast as you want. The wind will push the car down on the bottom of boats to lift them all the way up to big oil tankers. As the boat moves forward, it will lift it out of the water, requiring less force to push the boat forward. 1,000 sheets of this working wing can be put in a wind turbine. There will be so much torque created by the wind that the electrical contacts and the magnets can be put on the outer diameter of the circle instead of the inner, the outer circumference instead of the inner, so that you have a wind turbine that's 1,000 times the size for the same plane of rotation. The material stacked will give, when wind blowing across it, will give lift, propulsion, depending on whichever way you orientate the material. You put 100 sheets in and have 100 layers of working wing. All you have to do is move wind across it, or fluid. So that's 1mass1 unconfined. This material has numerous uses. 1mass1 unconfined also explains orbit, gravity, and everything else physical. So if I'm standing here on the earth, right here, the earth creates more disturbance on the force of me and my mass pushing up than pushing down, so I actually push myself toward the earth. If the sun's here, creating a weakness on this side of the earth pushes itself towards the sun. There's no such thing as pull, only push. If I say I'm going to pull a rope, if I actually look at it, my hands are pushing the rope. Or pulling a bumper, if I look at it from this side, my fingers are pushing the bumper. It's very confusing.